Hi guys, this is Korean Barista. Today I'm gonna show you how to solve two-sum problem. Then using your knowledge, you'll solve three-sum problem. This is very classic coding interview questions, so all of us should know how to solve this problem. Let's get into it. Okay, so here we have two-sum problem on a leak. So I loaded up on the leak code. It's like number one question, right? So given an array of integers, return indices of two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. As an example, given nums array is 2, 7, 11, 15, and target is number 9, because number 0, index is 0, plus nums at index 1 is 2 plus 7, which equals to 9, it returns array of 0 and 1, because 0s and 1 are index of number 2 and 7. Just reading this question, it's nicely bold here, but it says indices, not number, that match up to specific target. So that's one thing you have to pay attention to when you're writing your solution. And then in this line is really important. It says you may assume that each input would have exactly one solution. So this is really important right here. And this part is also important because you may not use the same element twice, so you don't have to worry about duplications of seeing number in the given array. So that's really good. In an interview setting, I would make sure to get everything clear before you get started. So first I'm gonna just try to solve this very brute force way. Then we'll spend some time talking about it and then find if there's any better way to solve this problem. So based on the question said two number will add up to a specific target. That means if you can get every matching pair, like for example for 2, 7, 11, for example, you can have 2, 7 as a one pair, 2, 11 as a one pair, and 2, 15 as one pair, then 7, 11, 7, 15, then that's it, right? So this is like a unique pairs of number that's not duplicate, meaning 7 and 2 are the same as 2 and 7, right? They're the same in different order. So for 2, 7, 11, 15, we have unique pairs of 1, 2, 3, 4, 5, 6, 6 pairs, right? Using this information, you can solve in a brute force way, which would be just looping through from index 0 as the first element, the length I++, then going from j equals I plus 1 because we want to use the one element after that, and j is less than nums that length, and j++. Right, so what this would do is starting, so I is 0 and j is 1. So then we will compare if nums at I plus nums at j equal to target, return I and j. Remember, I and j are indices. Cool. If there's no matching pair, if we don't have to worry about if there's no matching pair, because it's in the question given to us says you may assume that each input will have exactly one solution. So we don't have to worry about returning empty array because every time there will be exactly one solution. So I'm going to run this code. As you can see, you'll get 0s and 1 as expected. So runtime is 60 milliseconds. It's pretty fast, but there's one catch here, right? The runtime of this solution is, at a worst case, is 0 to n square. The reason for that is you have to loop through this nums array twice. Actually, if you want to get technical, this would be n times n minus 1, right? But in the polynomials, it will just be n square, right? So at worst case, it will go through array twice, right? This is okay. It's not perfect solution. We just got lucky here that 2 and 7 are in the first two elements. But imagine if there's like the nums arrays are like thousands of array, and then our solution was like the very last two, or the pair didn't match up until looking through everything, right? Then that means we have to come up with all the unique pairs and compare every one of them. So that'll be n squared, which is really slow. Ideally, we should be able to find a pair. So for this particular example, if target is 9 and the first number is 2, we want to look for number or indice that points to number 7, for example, right? And then we want to compare, store that information somehow, and then we want to be able to quickly retrieve that information. So this is let's talk about optimized solution here. So let's say, and then we discussed we want to think about in pairs, because there's two numbers that add up to a specific target. So for this, let's create a map, and then we can. It will be the same thing as the brute force solution. We will need to go through each elements in number array. But we only have to do this once. Before we went through, we update I and j, and then go through that list twice. But for this particular solution, we only have to do this once, which makes this runtime of all of n, which is super fast compared to all of n squared. So let's say we can define pair as target minus nums at I, meaning for this particular example, a pair is nums at I will be 2, right? So target is 9 minus 2 is 7, right? That's a pair we're looking for number 2. And then we can also check if map pair does not go undefined, meaning the map has a number 7 in there already. So that means that we already found it in as we're looping through. Then we can quickly return map pair and I. If that's not found, we want to update the map to have this pair as a key. The pair is a key, and then the value is the index. If not found, we can update the map with the current number, which is at index I, equals to this index. That means we have not came across the matching pair yet, so we're gonna track this number and its index into the map. So maybe down the line, when we loop through, we will see a matching pair, and then we will use that in here. Yeah, so map would actually take key is a number, and value is an index of a number. Okay, so let's run this. You'll see runtime is 92 seconds, 92 milliseconds, sorry. But we did get the right output as expected. You'll see the runtime of this is all of n, because we are looping through nums array just once, which is really good. Let's submit this, see what we get. Okay, 82. That's okay. Let me run it again. This thing depends on the memory speed, so that's okay. So let's look at, well, we're like more better than average, so you can see pretty much they're doing the same thing. So this is how you solve two-sum problem. Using what we learned from solving two-sum problem, we can apply that to solve three-sum problem, which is a little bit more complex but has the same idea. So let's get into solving three-sum problem.